More week 4. Uh, this is we're going to talk about double acting cylinders, and then a little bit about single acting a little bit later on in the week, perhaps. Double acting is a little bit more complicated. I have a schematic up here. What does it say at the top? In this video, we'll go over effective area, how much of the pistons area is used during extension, and that's with the rod going out. That's extension. So all the pressure's coming from this side with the rod going out, versus how much of the pistons area is used during retraction, and that's with the rod going in. Now, you may have noticed when you're curling a rod extending versus opening the bucket rod retracting, there's much more force when extended. And the reason is that when you're extending this in this situation, I hope everyone by now knows that's the piston, that's the rod, that's where the, let's say, the backhoe bucket or the other attachment hooks onto, such as a blade, lift, or whatever. So this is double acting. Uh, it has fluid going in on one end and coming out the other, and then pressurized fluid going from the one side to the other side to retract it, and a port to allow the fluid to go out. So let's just go over it. Look, right here is a reservoir. I know there's two reservoirs drawn, but in a schematic, it's just like another symbol. This port is going to the reservoir. This port is going to, this line's going to the reservoir, which is open. That's why it looks like a little U. It's a tank usually. So this is the pump, and it's probably taken fluid from the reservoir, and then it's pumping it up into this two-way valve. And I'm not going to go into all the intricacies of a valve, and there are many, but we later in the course will talk about those a little bit. But we need a two-way valve in this situation. We need a valve that will allow us to direct fluid flow coming out of here either in this direction or in this direction. Now, if you want to extend this, your control would open the valve, right? And the fluid would come in here and it would fill this empty space up until it started being restricted by the piston and the whatever tool was on the end here, or the bucket digging in the dirt. The pressure would build up, and uh, and in this case, we're given that we have 120 psi pressure, so we'll get to that. The pressure would build up until it overcame this resistance, pushed the rod out, curled the bucket in, and dug the ditch. And then when he came out of the ditch and pivoted the boom over to release the dirt, the material in the bucket, he would retract the rod. So he would, that lever would open, which is the control, pilot control, would open this side of the valve, let fluid come in, and it would push against this side, retracting the rod. And with there's a check valve out here uh, on this fluid line that when the pressure's off, the fluid only has one path it can take. When you're pushing, retracting the rod, the pressure's on this side, and the fluid in here is coming out, not gravity flow, but little resistance and into the reservoir, and then the piston is back here. So when he extends the rod, the valve on this side opens. I'm sorry, I just said that backward. When he extends it, the valve on this side opens. allowing pressure to push the rod out to curl the bucket or dig, for instance. And then when he wants to dump the bucket, he has to retract the rod. So your control allows fluid to come in here, pushing the fluid out of here and into there. And when the fluid is coming in here and the pressure's on this side extending, the fluid that's left over in here will come out with little restriction into the reservoir. So you got a piston, you got a pump, you got the piston is an actuator, and you have a pump, and you have at least a two-way valve. Gosh, these on excavators and things like that, you got, well, I'm not going to get into that right now. So we want to calculate the extended force. In other words, how much output in pounds per square inch are we going to have with this 4-inch diameter piston and 120 psi pressure. So first of all, do you recall what force what force is equal to? Force is pressure times area. Force is pressure times area. I wish I'd have put that up here, but I didn't. So make a note of that. You'll need to know that force equals pressure times area. And that's what I've asked you to calculate, for goodness sakes. So I'm in this video. I can't do it. Force equals pressure times area. How much pressure is on this area. So in the effective area of the cylinder, and remember I'm changing to this formula to save time. You take to get the area, you want to take 0.7854 times the diameter squared, which is 16. And for the effective area, which is this side, the side he gets to use, that we get the whole cylinder, it's 12.566 square inches on this side. Now, on the rod end area, it's which is 2 inches. The rod is 2. So to find the area there is 0.7854 times 2 squared, which is 4, gives us 3.1416 square inches. So you see there's a lot more area here, over twice as much than there is here. So let's look at effective rod end area. Now that's this end and this piston. You call it, we have what's called annular area. We have to subtract the area that the rod's taken up. So to find the rod end area right here, you take the area of the cylinder over here, which is 12.566, and you subtract the area of the rod, which is 3.1416. So to get the rod end area, you take 12.566 square inches minus 3.1416 square inches, and that gives you a rod end area. That's the area that's exposed to fluid, the area minus the area of the rod. That is 9 and 42/100, 9.42 square inches. When we calculate force, again, force is pressure times area, or like I have it written, area times pressure. So the extend force, that's when we're pushing this out where we need more force, times 120 pounds per square inch is 1,507 pounds per square inch of force in the extend force. But we jump down a little less here because we have 9.42 square inches of area times that same 120 psi of pressure gives us 1,130 and 4/10 pounds per square inch. So see, on the rod end, you're going to lose a little force because you're going to have a little less area. And folks, that's all there is to it. This is the very, very beginning of when we start. We will need all this preceding our calculations for actuator speed, and way at the end of the module, if we have time, we'll get into horsepower, which is interesting. So anyway, that's all for right now. Not going to go any further.